Okay, that started. Okay, good. So yeah, so the definition of a graph, and I guess you've already gotten this part, but that the graph of this function is z equals the value of the function, so 3x plus 2y. Now, how you understand what the set of solutions to this equation is, you have choices, right? And at a glance, it's not rotationally symmetric about any axis, and it doesn't look like a stretched out version of something familiar. But you know what? It is actually, in a different way, something that's already familiar. Because you could rewrite this as 3x plus 2y minus z equals 0, and equation of a plane. So we know it's a plane. We know the normal vector is 3, 2, negative 1. And you know it goes through the origin. And so that's enough information to draw what the graph looks like.
So how do you, my issues like actually draw?
Actually, the actual art component to it, yeah. Yeah, and by the way, I mean, broad stroke point, no pun intended, this is unavoidably a geometric class, right? Multivariable calculus is about multivariable stuff, which we have to understand by what it looks like. And the way we understand what things look like is by drawing pictures of them. So at least at a basic level, I mean, you don't have to be able to do shading and perspective and draw the human face and this kind of thing, right? But you have to be able to draw at least sort of decent, at least well enough to be able to conjure in the viewer's eye key geometric features. So okay, so let's draw this one. Right, so x, y, z, and let's see here. So we know we know our normal vector is 3, 2, negative 1. So let's try to draw that vector first. All right. Well, 3, 2, or something like that, and there's 3, 2, 0, but we're interested in 3, 2, negative 1, so that would be down here a little ways. There's 3, 2, negative 1. That vector then we might draw like that. Right, now this vector is mostly horizontal, but it's down just a little bit. Okay, so the plane, by the way, again, we've observed that this goes through the origin. So because it goes through the origin, I already know 1 point on this plane.
How do you know that it goes through the origin?
Because if you plug in x equals 0, y equals 0, z equals 0, the equation works.
Oh, okay.
Right? And a tip-off is that will always be the case if the right-hand side is 0. It's a tricky observation. So, all right, well, if this normal vector were actually horizontal, then I would be able to draw this plane by just drawing a vertical plane going through the origin that looks, perpendicular to that green vector. And so this is close. This is not good enough quite, because that's vertical, and that would suggest the normal vector is horizontal, which it's not quite, right? But that's sort of a starting point for your picture. And then you realize that, okay, well, all that we're dealing with is that this normal vector has been kind of kicked down a little bit, and so that's just going to make this plane kind of lean forward a little bit. So instead of what I just drew, let me do that instead. See what I'm saying? And now, let's judge my art quality here. Gosh, there's wambly little lines, and it's hard to visualize exactly what's going on there, right? So, I mean, this does not leap off the page and instantly make me realize exactly what this plane looks like. But there's something I can do to help, which is I can put a little right angle little brace there. So that absolves me of my artistic incompetence, because it indicates clearly that this vector right, is normal to that plane. Yeah, right. And I've also already indicated, you'll see here, well, I guess I should have written this on the picture. Let me put a 3 and a 2 and a, -1 like that. So even if my vector, my normal vector here isn't perfectly drawn, there's enough information to see that, look, what I was attempting to depict is this normal vector. It's exactly here. And again, the little perpendicular brace indicates that the plane is perpendicular to that. And so with those little visual assistances, this picture is good enough. Make sense to everybody? So it doesn't have to be beautiful. It's just got to be enough to communicate the key idea.
My question is also how you got from the 3 on the X coordinate and then the 2 on the Y. How did you make that specific dotted line? How did you know to make that?
Oh, well, the coordinates of this n vector are 3, 2, -1, right? So, well, I mean, those are the x, y, and z coordinates. So the x coordinate was 3, the y coordinate was 2, the z coordinate's -1. So, I mean, x means how far in the x direction, y means how far in the y direction.
Yeah, I'm saying with the actual, the dotted line.
Yeah.
Are you just drawing basically a plane, an XY plane? So
the purpose of the dotted lines are to suggest that, look, if the x coordinate is that, and if the y coordinate is that, then that means that the point that I'm interested in, its projection into the xy plane is there.
Oh, okay.
Right, and so that's just another sort of visual cue that that these numbers 3 and 2 are the x and y coordinates respectively of where that is, and then the fact that I have a -1 as the z coordinate, that's indicated by this point being, a little lower down there.
All right.
And look, my picture is getting messy here because of, I'm explaining on top of explanations, and so it gets a little muddled. But by the way, here's another thing I encourage. When you're drawing pictures like this, don't feel an obligation to get a perfect and beautiful picture on your first try. Right? Feel free to draw a bad first cut, be frustrated with it, learn something from learn what your mistake was. This picture isn't big enough. Or look at all this blank space up here. I don't need any of that. Right? 1/4 of the page here is completely useless, and I could say I'm going to redraw my picture, having learned my little lessons, and then draw a better picture. And especially on problems where you know that there's going to be a significant amount of picture drawing, you might strategize and don't do it on a piece of paper where you've already done other important work that you don't want to have to rewrite. Right? So take out a clean blank sheet of paper to do it on. Okay, is everybody happy with this question? Or do you have a question about this problem?
No.
Everybody good on this one? Okay, let's stop this recording.